Welcome to May 17th's LeetCode Challenge. Maximum twin sums of a linked list. And a linked list of a size n, where n is even and the ith node, zeroed index, of the linked list is the known as twin of the n minus 1 minus ith node. So this is basically the n node minus 1 minus ith position. If I is greater than or equal to 0 and less than or equal to n divided by 2 minus 1. It's a float division, by the way. For example, if n is equal to 4, then the node 0 is a twin of node 3, and node 1 is a twin of node 2. These are the only nodes with twins for n equal to 4. So the twin sum is defined as the sum of nodes and its twins. Sum of the node and its twins. Given the head of a linked list with even length, return the maximum twin sum of the linked list. So say we have the following. We have a linked list containing 5, 4, 2, and 1, and we want to find the maximum twin sum. So it's pretty clear that's highlighted here. The maximum twin sum is the sum of 4 and 2, giving 6. Notice that nodes 0 and 1 are twins of nodes 3 and 2 respectively. So basically, node 0 is a twin of node 3. Node 1 is the twin of node 2. Therefore, all the nodes, all the twins have a sum of 6. We also have basically 5 plus 1. So there are no other nodes in the twin linked list. Therefore, the maximum maximum twin sum of the linked list is 6. However, we see here that basically we have twin being 2 and 1, but they sum up to 4. But also we have twin of 4 and 7, 4 and 3, which sum up to 7. So therefore, the maximum twin sum is 7. And showing some pseudocode here. If we have 2 nodes only, then it's pretty obvious that the sum of the 2 nodes together is the maximum twin sum. So the number of nodes in lists is even, so ranging between 2 to 10 to the 5. The value of each node is between 1 to 10 to the 5. Alright, let's go about solving this. So we have kind of noticed intuitively that basically, given the head of a linked list, the problem states that basically you want to return the maximum of the twin sum. And twin sum is basically, if you give an even list, the definition of twin sum, meaning that we have a list, for instance, 1, 2, 3, 4, and 5, and 6. So basically 1 would be the twin of 6, 2 would be the twin sum of 5, and 3 would be the twin sum of 4. Therefore, the maximum twin sum of this linked list will be 7. So that's kind of the idea between that. So basically we want to be able to solve the twin sum and find the maximum of it. There are different ways to solve this. I think using a stack would be the most simplest approach. It's kind of straightforward, but not the best as well. So, say we require a method to obtain the values of a node in the second half of the linked list and in reverse order. So getting the values of the node is simple. We need to basically use head, which points to the first node in the list, and then using next we can iterate through all the nodes in the same way we get the previous nodes. So we can use a stack to get the values of the second half in reverse order. Then we just iterate through the linked list, push all the values of the nodes into the stack, and then compute the twin sums, iterate through that to find the beginning of the list and get the max value from that stack. And let's go about doing that. So first thing we want to do is create a linked list node pointer to current, initialize it to head. So we're going to initialize a list node called current and allocate that to head and point it to head. The next thing we want to do is initialize a stack, integer stack, to store the node values given the linked list. Let's do that as well. So we create a stack, and it's going to be a stack of integers, and we call it stack and new stack integer. Alright, next thing I want to do is iterate while current is not null. And there's two conditions we want to do in there, but iterate while current is not null. While current is not null, what we could do is push the stack the current value. Push current val. And then we also want to update the current, update current to current next. Where's this loop? Once we update current to head, we also need to update current to head to iterate through the list again from the start. So we gotta do that as well. To be head again. And then we also want to initialize some values to count the number of pairs and to create two integers. We can create integers called size as well and count. So this is basically cover the twin pairs starting from 0 and going to the basically going to the size of the stack divided by 2. So in order to do that, we need to initialize some values called size, which is going to be the size of the stack. We also want to initialize a integer count, and that's going to be 1 in the beginning. That should be good for now. And initialize something called max sum or maximum sum. We'll call it max sum. That's going to be 0 to begin with. Alright, next thing we want to do is basically create a. So this is going to be the variable that we're going to return to basically return the maximum sum of the twins. To keep track of the sum of the twins, initialize it to 0. So next thing we want to do next is do another while loop. This time we do a while loop checking for count is less than the size divided by 2. So basically it has to be between so basically the count has to be less than or equal to the size divided by 2, and then we could update max sum to be the maximum or max of the max sum, or the current value plus the stack, what's on top of the stack, but we need to peek it. Don't actually take the value, and then we update current pointer to current.next. We also want to pop from the stack to remove that value, and we want to increment our counter as well, so count plus, just to make sure that we're still inside the loop breaking condition. So we exit this loop, and then at the end of this we want to return our max sum, and there you go. Let's give this a little run. Let's submit it. So Alright, accepted. So you can see runtime isn't very good. Memory usage is okay. So this is basically the approach using a stack. Time complexity is big O of n, where n is the number of nodes in the linked list. Iterating through over the linked list and pushing all the nodes values into the stack takes up linear time. Space complexity is also linear time, so big O of n, where the stack takes up n space, because then we push all the elements into the stack. So the number of the nodes in the linked list is pushed onto the stack. Alright, and that is all. Have a great day.